Here us to graph each of the following functions and state the domain. So these are all going to be kind of sketches. I don't even have graphs here, so I'm going to kind of give us some x and y values, plot them on a graph, and it be kind of a rough sketch as we go forward. So the first one here is a rational function, which I know has vertical and horizontal asymptotes. So when I'm going through this, the first thing that I'm looking at is what are the asymptotes. And I know that my x value cannot be -2 because that would make the denominator 0. So I know that that tells me my vertical asymptote. The second thing is this is already kind of in transformation form, and because I see no k value, that tells me that my horizontal asymptote is at 0. The other way to look at that is we have the horizontal asymptote rules where if the degree of the bottom is greater than the degree on the top, then our asymptote is at 0. So vertical and horizontal asymptote I will sketch on here now. So we got -2 and 0. And from here, then it's just plugging in some x values that give me good points. Normally what I would do is I would find the x and y intercept, but because I have a horizontal asymptote at 0, there is no x-intercept. So now I'm just going to plug in some nice points that give me whole numbers. So first one I'm going to plug in is 3, because if I plug in 3, I get 5/5, which gives me my y value of 1. And then the other point that I will choose would be, let's say, 8, because if I plug in, actually, yeah, let's do a couple points. So we got 8, which if I do that, it becomes 5/10, which is 1/2. So there's one, and one more point here would be -1, because if I plug in -1, that would just give me 5. So -1 plus 2 equals 5/1, which just gives me 5. So kind of all over the place here. I wasn't super organized in this, but the first one that I got is -1/5, which would be up here somewhere. 3/1, 8 1/2, which is getting closer. And so I can kind of see that one of my curves is going to end up on the top right here, meaning the other curve would be over here. I could technically plug in some other values, but I'm going to just leave it as a sketch here. And then the domain is just everything but -2, right? Because we can plug in any x value we want as long as it doesn't make our denominator there 0. So for this one here, I'll go ahead and put it in interval notation. So my domain is -∞ to -2. I use our union symbol, and then -2 to +∞. Second one here is a square root function. I like to rewrite these as, when I say transformation form, just like a prettier way of looking at this, I guess, when it have the variable first here. So when I'm going to go through this again, really I'm just getting a rough sketch here. So I want to plug in some points that give me nice whole numbers. And I know some perfect squares that are going to make this easier. So first thing that I would plug in would be 3, because if I plug in 3 into here, -3 plus 3 is 0. The next thing that I would try plugging in would be 2, because if I plug in plug in 2, because then when I plug in -2 here, it becomes the square root of 1, which is just 1. And then the last one that I'll plug in here would be, let's just say, -1. And if I plug in -1, then it becomes a +1 here, plus 3, which is 4, and the square root of 4 is 2. So if I plot those points, we'll kind of see 2, 1, -1, 2. We'll kind of see that square root function shape here as we go to the left this time because of that negative. And so here's our square root function here. The domain on this one, because I can't do anything larger than 3 because it would make the square root negative. I have a domain here that goes from -∞ all the way up to +3 and then stops. Third one here is another rational function, but more so what I can see is that it's kind of like a reciprocal polynomial function. So to rewrite this a little bit, I'm going to factor the bottom into x plus 1 times x minus 1. Because then, scroll down here a little bit. because then when I'm trying to graph this here, I know that there are two vertical asymptotes at -1 and +1, because both of those are x values that would make the denominator 0, which would be bad. So I can basically have any function here, any x value but -1 or 1. So for the domain, it's going to look a little bit ugly, but -infinity to -1, -1 to 1, and then 1 to infinity. And this one here, so I know generally because it's a positive function that I'm going to be ending in this positive quadrant here. And so when I deal with this one here, again, just because of how often I've graphed reciprocal functions, I know generally where my curves end up here. If I wasn't sure, then I could just plug in points, right? Any points between -1 and then negative infinity would make it a positive number. Anything between -1 and 1 would make it negative. Anything to the right of 1 would be a positive value. And so this is our general sketch for our reciprocal polynomial, or 1 over x squared minus 1. Last one here is just a cubic function. So when I do this one here, I got 5x cubed plus 7. So again, I'll just make a little xy table, plug in 0 and get 7. That's my first point. I'll plug in a 1, which just gives me 5, 12. And then I'll plug in -1, because that gives me 2. Right, hold on. -1, yeah. -1, 2. So now I plot these points here, 1, 12, somewhere up here, -1, 2, somewhere down here. And so again, my general cubic shape with that 0, 7 being like my turning point, and there's a good sketch of my cubic function.